everyone. Today we'll do a very important topic, that is the Wheatstone Bridge. So, what is a Wheatstone Bridge? It is a combination of four resistors, galvanometer, and a battery connected to it. We'll draw a figure for the Wheatstone Bridge. We have the battery, four resistors are connected like this, and the galvanometer is placed here. We name the resistors at P, Q, R, and S. This is known as the Wheatstone bridge. There's a balancing condition for the Wheatstone bridge, that is, the bridge is balanced if the galvanometer, that is depicted by G, shows zero deflection. Which basically means no current flows through it. If this condition is true, then we write it as P by Q is equal to R by S. Now we'll derive this condition. To derive this condition, I'll zoom the figure a little bit and we'll mark it. We'll assume that current I is flowing from here. When it comes at this point, it gets divided into two directions, here and here. We'll take the current that is coming here to be I1. So this becomes I minus I1. It flows from this direction to this direction. We'll consider this as loop 1 and this as loop 2. We'll apply the Kirchhoff's law in this. We'll assume the current that goes through this gets divided here. This current gets divided here. It comes to be Ig here in the galvanometer. So the currents that left is I minus I1 minus Ig. That comes to the resistor Q. And it's coming here. The Ig is coming here. So I1 and Ig meet at this point and they get added. That is I1 plus Ig. And they separate out and then meet again in this point, and this current gets added to each other. So we again get I1. That is the current that entered into the loop is exiting the loop. So we have seen this is loop 1 and this is loop 2. Now derive just set the screen again. So we'll take two loops, loop 1 and loop 2. In loop 1, we can see that the current I minus I1 is flowing through P, resistor P here, and the current I1 is flowing through resistor R, minus IR plus Ig into G, that is flowing through the galvanometer G. In the second loop, we can see I minus I1 minus Ig flowing through Q minus I1 plus Ig flowing through S minus Ig into G is equal to 0. The flow of current that we took in these loops was this. So that is how we get the sign convention. So we'll solve it further. That is, according to the balance condition, the current through galvanometer is 0. That is, Ig is equal to 0. So we put 0 here. So we get I minus I1 into P is equal to I1R. And we also put 0 here, here and here. So we get I minus I1 into Q is equal to I1 into S. So we can write it as, let us consider this as equation 1 and this as equation 2. We'll divide equation 1 by equation 2. We'll get I minus I1 into P upon I minus I1 into Q is equal to I1R upon I1S. We can see that these two get cancelled and we get the condition of the balanced Wheatstone bridge, that is P by Q is equal to R upon S. We have derived and proved the condition of the Wheatstone bridge. So thank you, and I'll see you in the next video.